Now we're going to look at single replacement reactions. So back at our dance, Brad and Jennifer have been together for a long time, so of course they went to the dance together. Brad's fellow Glee Club member, Angelina, decides she's going to go alone. During the course of the dance, Brad and Angelina spend a lot of time talking about Glee Club activities. When My Heart Will Go On came on, Brad and Angelina were drawn to each other, leaving Jennifer alone in the corner. After quite the public confrontation, Brad and Jennifer break up. Then, Brad and Angelina became the new couple, and Jennifer was left single and alone. So this drama, this scenario, can be represented by the following equation. Right, we've got our couple, Jennifer and Brad, plus our single element, and they produce AB, okay, plus J. You can see that the A and the J switch places. The A replaces the J, forming this AB product, and then the J is alone. This is what we call a single replacement reaction. This will often happen when you have, oftentimes it's when it's a metal in a solution. A lot of times that metal will replace the cation in solution, as well as nonmetals can also replace nonmetals. So a couple things to remember, that with single replacement reactions, not every single replacement reaction will occur. Just because you put a metal in a solution doesn't automatically mean a reaction will happen. In order to determine if the reaction actually happens, you need to understand the activity series. Activity series will predict whether or not reactions will occur. So here is an example of an activity series. We can look and see that as you go down on this side, the elements become less active, meaning lithium is more active than lead. Okay, so if lithium is more active than lead, then it is, if lithium is more active than lead, then it is more likely to replace lead in a solution. But in the reverse, if, say, sodium is in a compound, then it is not going to be able to be replaced by something like iron. Okay, so here we'll look at how to actually use activity series, right? A metal can replace any metal below it that is in a compound. So let's do this example. Okay, solid sodium metal, right? So we've got our sodium metal, it's a solid, and a solution of iron 3 chloride, so FeCl3. And okay, so we have, here's our sodium plus our FeCl3, and it produces. Now we want to look at our activity series to see whether that sodium will replace the iron. So if we look, okay, so here is here is sodium and iron. Okay, so sodium is more active than the iron, and so yeah, it will replace it. So my products, I've got NaCl, okay, again, make sure you're writing your formulas correctly, plus iron. It's a solid. This is aqueous. Okay, and then we want to make sure that we balance this. Put a 3 here and a 3 there, and there's my balanced equation. Our next example, okay, we've got solid tin. So we've got tin, it's a solid, and it reacts with sodium nitrate, NaNO3. This is an aqueous, okay? And again, we want to look at the activity series. So let's look at, we have tin and sodium. Now sodium is more active than tin, so what happens is that the tin cannot replace that sodium, right? This tin here is not more active, so that tin will not replace that sodium. So you would write NR for no reaction. this reaction is not going to occur. The tin would just be sitting in that solution and nothing is going to happen. All right. Now let's look at one more example where we have nonmetals. A single replacement reaction can include nonmetals replacing nonmetals. So I have here my chlorine gas, so Cl2. It is a diatomic with sodium bromide. Okay. Now again, we want to look at the activity series. Okay, so look at the activity series, and here we're going to look on this side. So we've got we have chlorine and we have bromine. So chlorine is more active than bromine, so it can replace the bromine. So my products will be NaCl, okay, because the chlorine is going to replace it, and the bromine is now alone. Okay, and then I balance it. And so this is my balance equation. So single replacement can happen with a metal replacing a metal, or a non-metal replacing a non-metal. Okay, a metal can never replace the non-metal or vice versa. But you do need to make sure you use your activity series to determine whether that reaction will actually occur. All right, so now go and do the mini lab and the extra practice.